video, we're going to sort of review logarithms. So recall the notion of an exponent. And an exponent is basically the number of times a number is multiplied by itself. So if you say that 2 to the power 4, here 4 is the exponent, 2 is the base. This is equal to saying 2 times 2 times 2 times 2, that's 4 times 2, which we can also write as 4 times 4, and this is equal to 16, right? Now the logarithm is basically the inverse of the relation, so inverse relationship, right? So what does it mean? Let's look at this particular example. So we said that 2 to the power 4 is 16, and this implies, if you consider the inverse operation, we say that log of 16 is equal to 4. Now obviously the 2 plays an important role here. It's the base, and we would normally write it this way. Using our other relationship out here, we can also determine that log base 4 of 16 is 2, because 2 is the one that is in the power out here. Okay, so effectively the logarithm denotes how many times the base needs to be multiplied by itself, or to what power it must be raised to get the number 16 in this example that we've used. Now if the base is not specified, that is if we do not have this small number under the log out here, then you can assume that it's going to be base 2, which is sort of the default that we're going to assume for this course at least. You'll also realize that in many cases it does not really matter, and I'll probably do a separate short video on that. Now let's sort of get to slightly more interesting things. What we can do is that there are some interesting relationships on logarithms that we can define. For example, what is the log of some number n raised to the power a? Now this is equal to a times the log of n. Okay, now you don't necessarily need to put the brackets here, I'm just putting it for clarity. If we have the log of the product of two numbers, a and b in this time, so product becomes addition in the logarithmic space. So we will say log a plus log b. Note, I'm not specifying the base here. This is true for any base. We can also say log of a divided by b, and this is just going to be log a minus log b. Sort of just in ways of applying this, let's say that we want to compute log 1 over n. Now you could actually do it either using the first or the third relationship that we did. So in the first case it'll just be a would be minus 1, so this would be just minus 1 times log n, so minus log n. Alternately, we could apply the third one that we just did, and we could say log of 1 minus log of n. Now log of 1, basically what do you need to raise the base to so that you'll get 1, and that's just 0. So this is just 0, so you would just get minus log n. Okay, so that's just some simple relationships. Now one important thing I want to sort of go through, which is sort of a very common theme that we will be using in many of our simplifications, is what I would call as cancelling exponentials. Okay, now let's sort of quickly go about sort of understanding what this means. Say we have b to the power of log b x, right? So remember, we have b log b x, so it's sort of, you can see this cyclic type of a relationship, and this is simply equal to x. Okay, the alternate way of looking at this is that log base b to the power of x is equal to x. So let's sort of generally think of how we can prove these. These are fairly obvious once you sort of understand this, but let's just sort of do this properly in this case and then see where are they coming from, right? So what is happening here is that both are based on the basic definition of the logarithm itself. So if you think about it, b to the power c is equal to x means that log base b of x is equal to c. Okay, so this is what we're doing, and we can effectively plug one of these into the other and you would get that. So for example, if I take the second one out here and plug the value of c in here, we get the first one. Alternately, if I take the value of x here and plug it in here, we're going to get the other equation, right? And so